Hey everybody, Dr. Powers here. We're going to be taking a look at Project 2 in Math 240 here at SNHU. So this project is going to be looking at inference, one sample inference. We're going to be looking at t-tests and confidence intervals, and just kind of taking what you've done in assignment 5 and talking a little bit about what you did in back in module 6 and kind of synthesizing that all together into one project. Now, I want to go over the project scenario first a little bit, and then we'll go into some of the nitty-gritty about what is expected of you and some of the stuff that you'll want to be able to do in Excel to get a really good grade on this. So we're going to be once again looking at the real estate data. We're going to be considering a few different questions in this. We're going to be looking at the first question: are housing prices in your regional market higher than the national market average? So, like in some of the previous assignments, you're each going to be selecting one of the regions, and you'll be doing all your analysis on that one region. Okay. The second question is the square footage for homes in your region different than the average square footage for homes in the national market? So you can already see that what the first question is asking is the average listing price for your region higher than the national average listing price? The second question is the average square footage for homes in my region different than the average square footage for the national market? The third question is asking you to calculate a 95% confidence interval for square footage for homes in your market. Okay, now you have, so you're going to okay, so here let's get into the nitty gritty. We're supposed to pick a region, which region we're going to be looking at. Take a random sample of 100 observations. We're going to be talking about the sample that we've taken, and then we'll be talking about the types of stuff we'll be doing. Don't forget to include this last item, number 4, the level of confidence, discussing how estimation and confidence intervals can be useful, in particular to looking at the square footage question. So you'll be doing a one-tailed test. This is the question about the listing prices, and the next thing you'll be doing is the two-tailed test. And at the end of the two-tailed test, you're going to calculate your 95% confidence interval for the average square footage for this region and interpret it. Talk about this confidence interval. How does it relate to the conclusions from the test that you did? How is there anything different about your conclusion from the confidence interval versus the hypothesis test? That kind of thing. And then you're going to do your final conclusion. Okay, now of course I want you to use the template, Project 2 template. And keep the subject headings, but remove all of the bracketed text. So keep all the same subject or section titles. And now now we have the national statistics we'll be using and the house listing by region. That's what I'm going to download right now, and we'll go over the analysis that you'll have to do in Excel. All right, now I was born in Connecticut. I'm going to go to New England, and first thing to remind you, what do we do to get a random sample of 100? Remember, we're going to put random numbers in the last column. I'm going to type in the formula equals RAND parentheses, and that is my function in Excel that generates a random number between 0 and 100. Or sorry, 0 and 1. Now, every time you refresh anything on the page, all the random numbers are going to be regenerated. And so that's okay. What we're going to do is take that, copy it down to the bottom of this. This isn't the most efficient way to get to the bottom, but that's okay. All right, so we have a whole bunch of random numbers. I guess you might say they're pseudo-random because they've been generated by a computer, but that's fine. I'll put rand right here. And what I'm going to do here is I'm going to select all of this big block, and I'm going to go up to sort and filter. Sort, I'm going to do a custom sort. I want to sort by the random number. Okay. And what I'm going to do is I'm going to create a new tab, and I'm going to call it my sample. I'm going to copy. What I'm interested in is I don't care about cost per square foot, so I'm just going to go ahead and delete that. What I care about is rows. I'm going to just one, two, three. I'm going to just so that I know that I'm getting the first 100. I'm going to copy this pattern down all the way down till I get to past 100. Okay, I only need to go to 100, so I'm going to delete those. All right, this is telling me the rows of data that I want. I'm going to copy. Really, I just care about this stuff. I'm going to take these columns, copy that, go to my sample, paste it here, and I'm going to continue to do my analysis all in this. The first question is the mean listing price in this region higher than the national average? Okay, let's assume the national average is 270,000. It isn't, but I don't want to do the whole thing for you. So let's just assume that's the case. Okay, the null hypothesis here, I guess I'm gonna be giving this away a little bit, but that's okay, is that the mean listing price is equal to 27,000. Sorry, 270,000. The alternative is that the mean is greater than 270,000. Okay, so what do we need to calculate this? I'm going to get everything that I need. I'm going to get the sample mean, x bar. I'm going to get the sample standard deviation. I'm going to get the sample size. I'm going to calculate the t-statistic, and I'm going to calculate the p-value. So that's everything. Let's go through the formulas you'll need to do each of these one by one. First off, the average function gets you the sample average. Average, parenthesis, I'm going to go over here and select house listing prices from D2 down to D101. Okay, so there's my average. Obviously, that's way bigger than 270,000, but there's a lot of variation. And the question is this significantly bigger, which is to say, is that something we would attribute to a true difference, or could this be just due to the randomness of sampling? Well, this all depends on how much variation there is within this region. So that's going to be calculated by the standard deviation. So stdev.s, because it's a sample standard deviation. I'm going to go over, select that same range of data. Okay, that's my sample standard deviation. For some reason, that the formatting isn't preserved for that. I don't know why, but anyway, n is 100. I'm just going to put 100 there because I know it's 100. The t-statistic is found by taking my sample mean, x bar, minus the hypothesized mean, 270,000. I'm going to divide this by, in parentheses, the standard deviation divided by the square root of the sample size. Now the sample size is 100, so its square root is 10 exactly, but this would work even if the sample size was something else. This is going to give me my t-statistic. Now my hunch is this is going to be pretty massive, 5.69. This is what I would consider a massive t-statistic. Extremely unlikely to occur if the true mean for this region was 270,000. Extremely unlikely to occur. Now let's calculate the p-value. I'm going to do a t.dist.rt, a right-tailed, because I'm looking at the alternative hypothesis that the mean is greater than 270. Greater than means I'm doing a right-tailed test. I'm going to test how far out in the tail is 5.69. And the degrees of freedom, that's the sample size minus 1. I knew this is going to be basically 0. Now, this might look like a big number, 6.44, but that's times 10 to the negative eighth. That means you take 6.4413, you move the decimal place 8 places to the left. That's going to be 0.00000006, which is approximately 0. All right. So I'm not going to write everything out in your project. You're expected to be a lot more descriptive, but here's what I would say in this case. I would first of all reject my null hypothesis. The p-value is less than the significance level of 0.05. So reject the null. In other words, we have very, very strong evidence from our data that in New England, the mean listing price is greater than $270,000. And that's basically it. It would be extremely, extremely unlikely for a sample of 100 to look like this from a population if the population mean was 270,000. That would be almost impossible to occur because this sample mean is so much higher than 270,000. So that pretty much takes care of all the stuff you would need to do. Other things that you would have to look at is, of course, are you're going to actually. Oh yeah, the other thing that you'll need to do is we'll be looking to see if you've looked at the shape of the distributions, and the histogram is the main tool for looking at that. I skipped this, but you should have done this already. Now let's select the house listing prices and go under Insert, the statistical chart, histogram. Now you know from my videos I'm not a huge fan of histograms in Excel. I think they're fine. They're just poorly formatted. But anyway, you'd think it would put house listing price in here. You'd want to label that. You'll want to include a axis title, of course, make it look nice. But here. What am I going to say about this? Well, it's skewed to the right, right? And but my sample size is very large. So even though this is a skewed distribution, I'm justified in using the t-distribution to do this test because the central limit theorem kind of takes up all the slack. And the limiting distribution of t, my test statistic, is going to be a t-distribution, even though this population or the sample distribution doesn't look like a normal curve. That's okay because the sample size is so big. Let's take a look at the next question. Is the mean square footage significantly different than the national average? Let's assume the national average is, let's do 2,000 square foot. Okay, so here the null hypothesis is that the mean is equal to 2,000, and the alternative hypothesis is that mean is not equal to. Now I'm going to be a little bit lazy. I'm going to do this. Oh, that's really not very nice. For you want do use the proper not equal sign when you do this, but for here I'm going to just use this. Not equal to 2,000. I'm going to write it like that. I should also mention I don't want you writing the word mu. Go through a couple things. Go through the trouble of getting the Greek character. It's not that hard to do. I'm not doing it because I don't need to. But if I was going to set an example, what do? You go up to you can go to Insert, Symbol, search for your Greek and Coptic, which is like one of the subsets. Now, of course, it's different depending on what you're using. And then, yeah, you can find the mu is right over here. You can insert a mu and use that mu. That's the symbol we use for mean. Okay, it's a mu. It's not the letter U. If you use the letter U, I'll be annoyed. Anyway, let's calculate we're going to calculate the we're going to perform this two-sided test. Okay. Once again, we're going to need all of this stuff. I'm going to copy this stuff here, but I'm going to change some of it. Okay. So first of all, sample mean is going to come from the square footage column. The sample standard deviation also, of course, is coming from the square footage column. The sample size is 100, and the t-statistic, actually, it's calculated based on the difference between the sample mean and 2000. Well, what do you know? I got a very extreme t-statistic again. Now, for the p-value, I'm going to use a t.dist.2t. Now, when you do the two-tailed p-value, right, you want to use the absolute value of your t-statistic. I'm pretty sure it takes the right tail and it multiplies it by 2. The degrees of freedom, of course, is still 100 minus 1, 99. This should give me a very, very, very small p-value. This is very small, although it's not quite as small as it was for the first test. But again, the p-value is less than the significance level of 0.05, which we're going to use, and so we're going to reject the null hypothesis. Of course, I want to also let's include this histogram while we're at it. As far as square footage goes, we are going to insert a chart, a histogram, and now this is much more of a symmetric distribution, actually. So I would want to comment, first off, you want to change the title of that and make it look nicer. But yeah, I would say that the distribution is symmetric ish. It has some outliers. It has like these long tails, but yeah, it's symmetric, and especially considering there's a sample size of 100, there's no problem in using the central limit theorem here. Okay. Now, as far as the confidence interval for the estimation of the mean square footage for this region goes, you can do it in one of two ways. I'm going to show you I'm going to do it in both ways. I'm going to calculate margin of error as it's going to be, actually let's calculate the critical t-value for a 95% confidence interval. It's going to be t.inv.2t. I'm going to do the probability of 0.95 because it's a 95% confidence interval. Actually, I think I wanted to put 0.05. And then I put in the degrees of freedom, which is 100 minus 1. 1.9842. All right. Close to the 1.96 if you were to just use the normal distribution, but it's not quite the same. A little bit further out. Now, then the margin of error. The calculation is it's going to be the t-crit times the standard deviation divided by the square root of the sample size, 100. That's going to be the margin of error. And so my 95%, my confidence interval, my lower bound, and my confidence interval upper bound. Okay, these are going to be calculated. The lower bound is calculated by taking my sample mean, minus this margin of error. And the upper bound is found by taking the sample mean plus the margin of error. Okay, easy enough. The other way you can do this is you can use it's confidence.t. Okay, you have to give the alpha, which is 0.05. That's the significance level of the test we had done. The standard deviation, which is up here, and then the sample size, which is here. I should actually put this up above. This is the margin of error. That's what it calculates for you. And so, of course, you can just it's the exact same number. You just add and subtract it from the from the sample mean. So what can you say? I would want to see a statement that's something like this. I am 95% confident that the mean square, yeah, so the I'm 95% confident that the mean square footage for houses in New England is between 1,828 and 1,925 square feet. That statement. And then you would say, because you could say something about whether or not the assumed or the null hypothesis mean, that 2,000 square feet, if that was lying in that confidence interval, that would tell you something, right? But if that's far outside of the bounds of that confidence interval, then that tells you that it's not plausible based on the data that you have. The data that I have, it refutes the hypothesis that the mean for this population, this region, is 2,000. That's extremely implausible based on the data. You can say that because the p-value is really low, also because 2,000 does not lie within this confidence interval. All right, that covers all of the kind of analysis and everything you'll need to do in Excel that for this project. And so hopefully there's no issues with any of that. The rest of it is just what you write up and how clear you are in your explanations. So anyway, that is that, and I look forward to seeing what you submit. Take care. Bye.